One of the awesome things about developing for Android is the sheer number of devices that your code can run on, from the Nexus One and Pixel, to even other form factors like tablets, Pixelbooks, watches, TVs, and cars. When you write for Android, you don't write completely separate apps for all of these different devices. Even radically different form factors, such as watches and TVs, can share code. But there are still constraints and compatibility strategies that you need to be aware of to support all of this. The first thing to mention is the API level. Remember way back when at the start of the lesson when we selected the API level for our app? The Android OS has different version numbers which map to API levels. The version numbers, in turn, are named after tasty treats and are in alphabetical order. This started with Android Cupcake, which maps to API level 3. The OS version names are such a big deal that developers will often guess dessert names in anticipation of the next launch. Each OS version ships with new features and functionality. For example, in Android Oreo, we shipped with picture-in-picture apps, while in Android Pie, we introduced slices. Due to a number of factors, including what the hardware can support, whether users choose to update their devices, and whether manufacturers support different operating system levels, users will inevitably end up on different operating system versions. Your minimum SDK determines who can actually use your app. If your minimum SDK is 19, like we've chosen, that means that anyone running API 18 or lower won't be able to install or run your app. So you might be wondering, why not just set everything to min SDK 1 and be done with it? Well, this right here is the Nexus One, and it runs Android Gingerbread, also known as API level 10, which at the time of its launch in 2011 was pretty state-of-the-art. The thing is that a lot has changed since 2011, so much so that the way that you interact with the OS and the actual code that you write will end up being different for API level 10 than for API level 28. So for example, this device has an options menu key, a search key, this little trackball down here, and limited multi-touch support. One way to handle all of this is that you can add logic to your code which checks what OS version your user is actually on and then uses certain classes, libraries, and features accordingly. But maintaining all of these separate code paths adds a lot of maintenance overhead. So instead, it's important to think about what API level your audience is actually on. When you're setting up your project, you can take a look at the Help Me Choose dialog, which gives information both about how many devices use different OS levels and also the features that were added or changed in that OS level. You can also check out the Android documentation, release notes, and the dashboard. In some cases, it might not even make sense to support devices below a certain API level. For example, let's say that you're working on a public transportation app that uses Bluetooth Low Energy. This is a more efficient version of Bluetooth that's used for a lot of products like smart devices and beacons. It wasn't fully supported by the OS until API level 18. Thus, for your app, you would never really want to support API level 17 or below. The one thing that you do not want to do is to write code that will crash on older devices. This will lead to sad users and bad reviews for you. Writing for different Android API levels is such a common challenge that app developers face that the Android Framework team has actually done a lot of work to help you out. In 2011, the Framework team released the first support library, a Google-developed library that offers backwards-compatible classes and helpful functions. Now in 2018, Google announced Android Jetpack, which is a collection of libraries that includes many of the previous classes that were in the support library, and it also expands on top of the support library. Android X is the namespace for Android Jetpack, so import statements with Android X refer to Jetpack libraries. You can see an example of this in your code. Your main activity class extends from AppCompatActivity. AppCompatActivity is a compatibility class that makes sure your activity includes a menu bar, known as the action bar, that looks the same across different platform OS levels. And what am I talking about? I'm talking about this menu bar up here, again known as the action bar. Okay, so back in our code, if I scroll up a little to these import statements, we can see that AppCompatActivity is part of Android X. Furthermore, let's go ahead and open up the Gradle file for our app module. And if I go down to the dependencies block, I see that AppCompat is a dependency of our app, and that it's also a part of Android X. The libraries of Android Jetpack come with the documentation and tools that you need to make great modern Android apps. We're going to be relying heavily on Android Jetpack libraries and the accompanying tooling, documentations, and best practices throughout this entire course.